day everyone, we are the group 4. So for today, we are going to discuss to you the organic compounds with nitrogen, the short summary of IUPAC, nomenclature, organic compounds, and the chain and rings form. So to our viewers, please listen as we start our discussion. Starting with the organic compound with nitrogen. We know that nitrogen is a common element in our universe, a non-metal and the lightest member of group 15 in our periodic table. It is used to make fertilizers, nitric acid, nylon, dyes, and explosives. Nitro group has functional groups. These are the amines, amides, nitrile, nitroamines, nitroarenes, and peroxyacyl nitrates. So let's go with the amines. Amines may derive from ammonia by replacing 1, 2, or all 3 hydrogens with alkyl groups. So here is an example. The terms primary, secondary, and tertiary refer to the number of hydrogens that have been replaced. Both primary and secondary amines are capable of hydrogen bonding with themselves, but tertiary amines have no hydrogens on the electronegative nitrogen atom. So let's go with the second one, which is the amides. Amide is another important nitrogen-containing organic compound. The key feature of an amine is a nitrogen atom bonded to a carbonyl carbon atom. If the two remaining bonds on the nitrogen atom are attached to hydrogen atom, the compound is a simple amide. If one or both of the two remaining bonds on the atom are attached to alkyl or aryl group, the compound is a substituted amide. The reaction between amines and carboxylic acids to form amides is biologically important. It is through this reaction that amino acids link together in a polymer to form proteins. The third nitrogen that contains organic compound is the nitrile. Nitrile functional group consists of carbon-nitrogen triple bond with one substituent. Some examples of nitriles are found in superglue and also rubbers. Nitriles are colorless solids or liquids with distinctive odors.
Nitrosamines has the chemical structure R2N minus N is equal to O, where R is usually an alkyl group. Examples of nitrosamines include cured meat, some cheeses, non-fat dry milky, and sometimes fish. They feature nitroso group bonded to a deprotonated aniline. Most nitrosamines are carcinogenic in non-human animals. Nitroarenes are large class of structurally related chemicals normally found in particular emissions from mini combustion sources, most notably diesel exhaust. Example: gasoline and diesel's exhaust. Peroxyalkyl nitrates. It is a secondary pollutant present in photochemical smog. It is thermally unstable and decomposes into peroxyethanoid radicals and nitrogen dioxide gas. It is a lachrymatorial substance, meaning that it irritates the lungs and eyes. Some of these compounds are directly emitted into the atmosphere from industrial emissions. For example, emission of amines from sewage treatment or waste incineration, and emissions of nitroarenes from fossil fuel combustion.
Alkanes and cycloalkanes. Alkanes are the family of the saturated hydrocarbons. These molecules containing carbons and hydrogen connected by single bonds only. These molecules can be in the continuous change called linear or acyclic, in the rings called cyclic or alicyclic. The names of alkanes and cycloalkanes are the root names of organic compounds. Beginning with the 5 carbons alkane, the number of carbons in the chain is indicated by the Greek or Latin prefix rings are designated by the prefix cyclo. In the geometrical symbols for rings, each apex represents a carbon with the number of hydrogen required to fill its balance. Some common examples of cycloalkanes are thus as shown below in the image. Carbon atoms present in the compound design and structure of cycloalkanes.
Naming substitute of alkanes inside the cycloalkanes, which was for group C substituent only, we should follow the step for naming organic compounds. Here are the steps. Una, hanapin ang may pinakamahabang carbon chain. Alamin ang root name ng parent chain sa cyclic compounds. Actually, ang ring ang itinuturing na parent chain. Una-unang sinusulat ay ang salitang cyclo before the root name. Pangalawa, number forward and backwards. And third, determine the name and position number of each substituent and indicate the number of identical groups. Pang-apat, place the position number and the names of the substituent group in alphabetical order before the root name. In alphabetizing, ignore prefix like sec, tert, di, tri, etc. but include iso and cyclo. Always include a position number for each substituent regardless of redundancies. For example, hanapin may pinakamahabang carbon chain which is the 3 carbons. Pagkatapos ay alamin ang root name nito which is the alkane because it has 2 bonds. Then put a number on each substituent from 2 to 3 at this has only 3 carbons and backward number again like this. Pagkatapos ay alamin kung saang numero o posisyon nakalagay ang bromo at ang kloro. Nasa 2 ang bromo at nasa 1 naman ang kloro. Remember, ang pinakamahabang number ang dapat ilagay in giving name at alamin ang pangalan ng 3 carbon which is the propane. So, the name of this example is 2 bromo and 1 chloropropane.
Now let's take a look at this compound. So what's interesting here is that there is a chlorine in here. But again, first ignore the chlorine and look at the longest continuous carbon chain. So let's go ahead and number it forward and backward. And we have 1, 2, 3, 4, 5 carbons, and I'm going to number it backwards also. So if we ignore chlorine, what is the basic name here? It's 5 carbon, so that's a pent. And as you can see, there are only single bonds here, so it's a pentane. Now this chlorine is a halogen, and so that's our functional group here. So we have the halogen functional group. And remember, for halogens and for the alkyls that we had done, the name goes in the prefix. So it's going to be a chloropentane, not chlorine pentane, it's chloropentane. So that's the way IUPAC name is done. And we also need to give the position. So what position of chloro should I give here? Is it going to be 5 chloro? No, it's 1 chloro because we'll choose the nearest number, the smallest number here. But there's no need to actually write 1 chloro here because the number 1 is not necessary. So simply the name is going to be chloropentane.
In alkanes, change the A and E to E and E, like propane to propene. Ang alkanes ay para lamang sa dalawang bonds. For example, ito ay may 4 na carbon na ang tawag ay butane at ito ay may 2 bonds. Unahin isulat ang butane bago ito palitan kaya the name of this example is butane. Same din sa alkynes. Ang alkynes ay may 3 bonds. Palitan ang A and E sa Y and E. For example, ethane, 2 carbons. Yung alkyne naman is equals to 3 bonds. So, the name of this is ethane. Tas ipapalitan natin ng ethane, yung Y and E.
So again, we'll number our carbon chain forward and backwards. So it's 5 carbon. We'll ignore this for a moment. So that's the simple way to do it. So you'll have a pent and only single bonds, pentane. Now again we have some halogens in here. So there are 2 chloros and a bromo, right? Now there's another rule that comes in here when you have a bromo and a chloro, you need to go in alphabetical order. So B comes before C. You shouldn't consider the dichloro. The D is not important. We are comparing bromo and chloro. So the name bromo will come here first. So there's a bromo and there's a chloro. Sorry, dichloro, right? So there's a bromo and dichloro. But we also need to give the numbering. And remember, we need to choose the smaller numbers. So we won't go for this scheme, we'll go for the backward scheme. So you can see that there's a 1, 2 dichloro and a 3 bromo. So I'm going to rewrite this name again as, so let's cancel this out. It's going to be 1, it's going to be 3 bromo, right? So the bromo is at position number 3, and after that we have 1, 2 dichloro, correct, and pentane. So note these things carefully, that between the number and the letter, you can see there's a dash. Between the numbers, there's comma, and there's a number and a letter here. So again a dash, and we went in alphabetical order. Bromo B came before chloro. So you can see it's a 3 bromo 1, 2 dichloro pentane.
Let's proceed to the naming molecules containing functional groups from group A, prefix or suffix. In naming molecules containing one or more of the group functionals in group A, the group of highest priority is indicated by suffix, and the other are indicated by prefix with equivalent priority equal to any other substituents. So first, let us know what is a prefix and a suffix. So both gives you information about the functional groups and other substituent presents. So suffix and prefix give you both functional groups and other substituent presents. Modified set of steps of naming organic compounds can be applied to all simple structures. Let us proceed to the step 1. Step 1. Find the highest priority functional group and determine the name of the longest continuous carbon chain that includes this group. Step 2. Number the chain so that the highest priority functional group is assigned to the lower number. Step 3. If the carbon chains include multiple bonds, group B replace an with ene for an alkene or ene for alkyne. Designated the position of the multiple bond with the number of the first carbon of the multiple bond. Step 4. If the molecule includes group A functional groups, replace the last E with the suffix of the highest priority functional group and include its position number. Step 5. Indicate all group of substituents and group A functional groups of lower priority with a prefix. Place the prefixes with appropriate position numbers in alphabetical order before the root name.
See the example. Here we have a 3-carbon chain with 2 functional groups. One is the carbonic acid and second is the MI. As we know, the functional group priority should be given more to the carboxylic acid than MI. So we'll start the numbering from the carboxylic acid. So there is 1, 2, and 3. Now base name is propane, where we have to replace the E with the what are the suffix for the carboxylic acid, that is the E should be replaced with the oic acid. So now it is propane minus E plus oic acid, that is a propanolic acid. is the root name for this compound. Now amide group is present at the third portion. So 3-amino. So the complete name of this compound is 3-amino plus propoic acid. That is 3-aminopropanoic acid.
Next is naming carboxylic acid and derivatives. The 6 common groups derived from carboxylic acids are the salts, anhydrides, esters, acyl halides, amides, and nitrites. Salts and esters are most important. First, salts of carboxylic acids. Salts are named with cation first, followed by the anion name of the carboxylic acid, where ic acid is replaced by 8-acetic acid. Becomes an acetate, butanic acid. Becomes butanate, cyclohexane carboxylic acid. Becomes deoxycarbohydrate silate. Esters. Esters are named as organic salts. That is, the alkyl name comes first, followed by the name of the carboxylate anion. Common abbreviation is COOR.
Good day everyone. Our topic that we are going to tackle today is all about change in ring form. So first, let's start introducing the carbon, which is essential in our life and also important in many areas of the chemical industry, which also can form chains. Carbon is the only one that can form stable linkages to itself as well as to other atoms, such as hydrogen and oxygen. Now, let us now proceed in our main topic. Carbon can form a huge carbon chains and can connect it to other carbon atoms. To make the change in ring form understandable, the chain will occur if the carbon will be connected to the compound with the same chemical formula to make a ring pattern. So, here are the some examples provided to make it clear. Presented here is the structure of glucose, wherein the carbon is presented combined and connected to its coordinating compounds that makes chains form the left side of ring form in the right side.
Now, I will present the example of chains and ring form of an atom to form bonds with other atom. The first structure shows the straight chain, which consists of carbon atoms connected in continuous straight line. The second one shows the branches chain, in which an open chain of atom which one or more side chain is attached to it. And the third one is the ring form or the cyclic chain, which the carbon chain joins to itself in a ring and has atom of at least 2 different elements as member of the ring. And another example showing the structure of different chain and rings form of specific atom chain number 1. It shows here the straight chain, which are the 18, propane, and the butane. Number 2, which shows the branches chain with the compounds called pentane, isopentane, and the nepentane. Finally, the rings form and the cyclic chain with the example compounds of glucose, fructose, and sucrose.